it's not my goal to teach you programming here, but I'm going to give you a little bit of an explanation of how this program was written, simply to show you how we're using the mathematics and the Coulomb's law, the definition of electric field, equal potentials, and so forth, because it's kind of neat. And it's not that hard to follow. Now, you don't have to learn how to do this programming. Just very briefly, at the beginning, we set up the screen window from negative 13 to positive 13 in the x and negative 10 to 10 in the y directions. We print out a little message here, and then we ask the user to input the charge, which we'll call Q1. That's charge 1, and its coordinates, x1 and y1. Then the charge Q2, its coordinates x2 and y2. Then the program draws a circle of radius 0.05 on this screen scale about x1 and about x2. Now actually I need to modify the program. I thought I'd made a modification to color those circles. In any case, this explanation is on the page, incidentally. I say here we set up a loop to plot the field lines. And actually this message is incorrect. That's been deleted out of the program. And should be deleted from your page. Okay, now there's this thing called choice. We're choosing between choice equals 1 and choice equals 2. I had to misspell choice because it's a reserved word in the language. I do know how to spell choice. It's got an E in the end, C-H-O-I-S-E. In any case, if choice is 2, tells the plotting routine whether we're going to plot field lines or equal potentials. Choice equals 2 plots equal potentials. Choice equals 1 plots field lines. So we're going to plot the equal potentials first, although you won't see that until we get down to the plotting program. So to plot the equal potentials, we let XX stand for the x coordinate. We don't want to call it x because we want this to remain static while the field program changes the values of x. We don't want it changing the values of the x in our loop. So just from negative 13 to 13, that means we go across the screen from x equals negative 13 to positive 13 in 26 steps. And from each point that we get along the x-axis in those 26 steps, we're going to plot an equal potential. We plot the equal potential pretty easily. We just let y be a little bit less than 0. We do that so that the equal potential will plot in the lower half of the screen, or we'll plot the equal potential below the x-axis so as not to use up the whole screen, so we can see things a little better. And x is just going to be whatever the x-coordinate is here, from negative 13 to 13. And then we set the point x, y. That means we just set a point on the screen with these coordinates. And then we go to the field plotting routine. The command to go to the field plotting routine says we call field line. And the routine will plot an equal potential. It plots the equal potential because it knows that the choice is 2. We call that parameter. That parameter gets passed to the program. That just means that the field line program knows that our choice is 2, and it knows that we just plotted the point x1, xy. Okay, and when we see how that program works, we'll see what it does there. So we start with a point xy from negative 13 to positive 13, so one of those points, and we call this program with choice equal 2, and it'll plot an equal potential. Next thing we do, and the next here completes the loop. It's a for next loop. We said for x equals negative, x equals negative 13 to 13. We end the loop by saying go to the next value of x until you're done, and then go on to the next step. Okay? Now we set choice equal to 1, choice equals 1, so the program will know to plot field lines. We let q equal q1, and we set this loop. It says for theta equals 3.14 over 48 to 3.15 by a step of 3.14 over 24. Now that might seem kind of mysterious, but there's nothing to it. It just means that theta starts off at 1/48 of pi. That's pi over 48. Small angle. And it goes up to just a little over pi. And it does that in increments of pi over 24. So we start at pi over 48, and we go to a little over pi in increments of pi over 24. And that's going to take us in a circle around the point. And as we circle around that point, we're going to plot a point, and then we're going to plot the field line that comes out of that point. Then we circle a little further, plot a point, plot its field line. So we just circle around the point and plot field lines as we circle around the point. And that's really all that goes on here. We use a little trigonometry. Remember, x1 and y1 are the coordinates of the point, or the coordinates of the charge, and we just let x equal x1 plus the cosine of theta, y equal y1 minus the sine of theta. Now, if you understand your cosine and sine of theta, you see that that's going to put us at a distance of 1. This is x1 plus 1 times the cosine, y1 minus 1 times the sine. It's going to put us at a distance of 1. xy will be at a distance of 1 from x1, y1 from the position of the charge. And in a direction that's at angle negative theta from the charge. We get the negative theta by going to the negative sine of theta. So if you just plot what that means for a few angles, you'll see that that just takes us to a distance 1 from the charge at an angle negative theta. We go to the negative theta so we can plot below the y-axis. And then we set the point. Okay, so this is a point at a distance of 1 from charge Q1. So if charge Q1 is here, and theta is, let's say, pi over 3, which would be up here. We're at negative theta, which is negative pi over 3. That'll be down here. So we're moving around progressively as theta goes from a small angle up to pi. And then we call the field line program. We're at this point. Here's the point. Here's the charge. Here's our point. We plot a field line starting from this point. And then we do the same thing for the charge Q2. We let Q equal Q2. Theta goes through the same values. And we set these points, and then we'll call the field line program. Okay, so that's how we work. We first set the points that start our equipotentials and our one at a time. We set the points that plot our equipotentials, and we go to the field line program. Okay, and this is the field line program here, and we'll go into that in a minute. We plot the field line or the equipotential, depending on whether choice is 1 or 2, and then we go to the next point. We go through all the equipotentials from x equals negative 13 to 13. Then we go through the field lines, starting by circling around Q1 and drawing the field lines. Then we circle around Q2 and draw its field lines.